I have not watched like any of those things recently. Actually, I'm in the part of winter where
You work a lot. You don't watch television.
hey, I got to respond to our team. I need you guys to try to take on this challenge, but you cannot use the formula that you know.
Why? I don't even know.
I thought we proved that formula.
Nope.
We didn't prove that formula?
We did prove that actual formula about something.
Using any method, though. Why is it cut off?
Some of them measure. Just copy it onto your paper.
I don't want
Life
to.
hack, protractor.
Okay, we can make triangles.
Well, that's kind of a lame way to do it.
Well, that's the
You're right.
I mean,
You're right.
Exactly, I'm right.
Well, if we make a line from there to there,
That's what I'm gonna do.
wow, that's a kind of lame way to make a line. I'm gonna be honest. Undo it. We should do it back.
Do it.
No. Yeah. Line. Are you just gonna connect each point to each other point?
No, and then that, so then we know that
Oh,
the
okay.
triangle has 180. Wait. Okay, now I can do whatever you want.
90 plus 9.
Where'd you get 90 from?
9.
Where'd you get what? Why 90?
The sum of these angles has to be 90. The sum of these angles has to be 90. So we just got one more angle. Oh no, I'm wrong. You're wrong.
Hey, that's what I thought. Okay, I was gonna say. Okay.
You're allowed to speak up. All because I'm like texting on my phone doesn't mean I'm not listening to you guys. You guys, I've explained to you guys that we have a whole school text message, right?
Yes.
So like, why? To take care of things instantaneously.
Like, remember when Nate busted out of the classroom in Spanish? Miss Gabbard had to text the teachers, where is Nate? To make sure he was okay.
So if you ever see me just wandering around the school looking like aimless, especially if I have my radio, it's not me aimlessly wandering. I'm out there with intention.
With intention.
With intention.
It's 30 plus 240.
So-
It's 540.
If somebody walked up to you and asked you how many degrees are in a polygon,
I would tell them to search it up.
and you told them 180 times n minus 2, they wouldn't understand what n minus 2 meant. They
I
wouldn't
don't
understand.
understand what
N is the number of sides.
So this is why
okay.
today we're going to derive the 2 ways that defend that formula works. So one of them is this way, where you have broken up your polygon into 3 triangles from one of the vertices.
That's what I just did. Just copy
I know, I agree. So I'm copying what you did. So there's 180 degrees between those 3 angles, 180 degrees between those 3 angles, and since we know that this angle is the sum of these 3 angles, we know that with these 3 180 degrees, we hit all of the angles of the polygon and none extra. But there is another way, and not just like from another vertex. There is another way that leads us to that formula.
I think it involves
I think it involves exterior.
Sorry, what's your question?
Why do we know that the sum of the angles is like
So, I appreciate you asking. Because I feel like this class, you guys are like, often don't ask lots of questions. So A plus B plus C equals 180, right? D plus E plus F equals 180. And G, H, I equal 180. And since we have angle B, really this is one angle. Angle C, angle E on it. Angle if,
No, it's angle fit.
angle phi, right? Or angle H, and then GDA.
Good up.
Good.
Good.
Yeah.
Good up.
Dag.
Okay.
Angle dag. So all of the things that we've referenced are angles on the polygon, right? There's no like extra angles that don't belong. So this is the cleaner proof, actually, because it only involves 3 triangles, and then you can see, well, the reason that a 5-sided shape can only make 3 triangles. Anybody? Like, I'm sure that if I put a 6-sided shape up there, you're going to tell me
You
you
can
can
make
make
more
more
than 3 triangles,
But why?
Mr. Hudson.
I don't know why.
Mr. Hudson,
I just
what
know
are you
it's
on
5
about?
minus 2.
Triangle. Triangle. Pentacle. Where is the missing side? Okay, there we go.
Close to a
I was
pentagram.
like, where's the missing side for the third?
Awkward pentagram.
Oh my
Yeah,
god, it's a
pentagon.
star!
And it's got more
Non-symmetric.
It's a star.
It's a pentagram.
What?
Well,
Because the only reason a pentagram
It's
is
not
a pentagram is
regular
that penta is 5.
pentagram.
What? It's a pentagram.
But it's a
Oh my
pentagram.
God.
Alright, so
Well,
with
you
the
gotta
other...
make the circle.
The other proof doesn't make as much sense, so I feel like I have to take you guys to it just to make sure that you like recognize it. Because what will happen is somebody will show you a partial proof, right? Like a test or a future class might show you a partial proof and say, okay, fill in what we're allowed to fill in. So I want to make sure that you've seen this. I know it doesn't make as much sense as doing that, at least before Connor put the extra lines on there.
Well, you said you couldn't make for a triangle.
Well, clean, like on their own, not overlapping. We can make 3 clean, distinct triangles. How could we
Wait,
make...
yeah, Jake, do it. Yeah!
No, but that's not a vertices. So I mean, you couldn't say something definitive, but like, I don't even care. I'll just take back what I said. But fine, if you guys feel like doing challenges, fine. Leave this here.
Just make it there I go. Yeah!
Less dramatic than tossing it onto the tray. I want you to make clean, distinct, not overlapping, using vertices. I want you to make 5 triangles. Now, I'm not saying you can only
You're
use
not
vertices.
overlapping?
I'm not saying you can only use vertices, but I am saying so. We can also make 5 triangles in here. Clean, not overlapping,
Kinda
all
clean.
adjacent to each other. Kind of. If we had a nice center point and we had the computer helping us, the lines would look like they line up better. So then, how could you use this to make a proof of why the n-2 times 180 works? This we know works, but what if we're not allowed to use that way? What if we have to use this way?
Well, you know the sum of this. Okay, let's see what we do now.
Do it in your best handwriting and not in a highlighter.
My best handwriting.
Yes.
You could shrink down the pen a little bit if you wanted to be nicer.
We have an actual pen.
It's like the thickness.
Yeah.
Sorry.
Take, okay, or ignore it. Yeah, okay. Great.
We know the sum of these angles has to be 180.
Okay, look. That's not that bad.
Well, you give compliments like my wife.
Okay.
Okay.
That's actually a good idea.
Actually, I
It makes
say
me
that
feel like
too.
you're surprised that I had a good idea.
Okay. But then we also know if we take green shape, we're gonna be special here. We take green shape.
I'm so confused.
You know the sum. Wait, does that even help us?
I don't think
You were on a good track.
I mean,
I can't see anything.
Right? Because
Then
like
move.
we know, Jake, stand your butt up. Problem solving.
Only your butt.
Yes.
Just your butt.
Well, what else is on the chair? Actually, his hips on the chair. Yeah, keep your hand on the chair. Just stand. Okay.
Just like this.
Like we know.
well, this, okay, you know what?
Yeah, that doesn't help.
So wait,
Okay.
you right now, if we get rid of green shape,
Green.
you right now have 5 times 180.
Right.
But
We need to
have
justify-
subtract these bits here.
Yeah.
Okay. Well,
Wait,
then-
we know that's 360.
Exactly.
So
That's what I was
maybe-
thinking. So you could do 180 times 5 minus 360.
We're gonna make a new green shape, okay, guys?
Okay, make your best circle or just use the. Okay.
Make an amazing green shape.
Okay, there is the green shape. It's a perfect circle. Actually-
180 times 5.
It doesn't really even need to be a perfect circle. Whatever.
Do 900 minus 360.
Well, 360 is 2 times 180.
That's true.
So, since every polygon, so here's our proof. Since every polygon of n sides, so an n-gon, right? This is literally what we call an n-gon. An n-gon can become n triangles.
Whoa, what about a nonagon?
That's 9. Right?
That's 9. Nana literally means 9. So then we have n times 180.
Right.
However, we need to take away that central angle, which is always going to be 2 times 180, or 360, but if we want to talk in 180s, so that we can then, Jake, you with me? Because you might have to show this on a test at some point. I was tutoring a student last night, and he was like, hey, we got asked to do this proof in class, and I have no idea how to do it, and I still have no idea how to do it. And I realized, like, I want to make sure we review these things, because in case it comes back around on a test. So that proof was about the 30, 60, 90 triangle.
Oh my God.
And I don't know if you guys remember how we did that, but we started with an equilateral
Yeah,
triangle
and then you just.
and dropped it to make a 30, 60,
Yeah.
90.
I saw that on
It's
an
this sort of
SAT
stuff.
question.
Right? Hopefully once you've seen it, you can bring it back.
Wait, SAT?
Yeah, you can take the SATs whenever. Like once you're like 12.
I
you can-
know, I've taken it.
Yeah, so there you go. So
Wait, maybe that's
this,
the
if I like reverse distribute or factor, right, I can do 180 times n minus 2. And that is how we can derive that any polygon does not have to be equiangular, does not have to be equilateral. Any polygon we can use this formula with.
Great. Okay.
Great.
So
Green
we can
shade
test
is my
tomorrow,
favorite.
and are you not going to be here tomorrow?
Correct and correct, Mr. Leifeld. I don't know if you remember Mr.
We're
Leifeld.
having a different stuff.
He subbed. It's not going to be Mrs. Cullinan because she's now Mrs. Lemire for the week. Mr. Leifeld, we know each other outside of school, and he's getting his master's in teaching, I think. So he's like not a day-to-day teacher right now, so he subs. So he knows math. He can talk math with you guys, but I'm still going to let you guys take your test. So, that's still the lesson plan. Not I'm going to let you take your test. I'm going to ask you to take your test.
What if I just don't feel like it?
The first, especially because I'm concerned about your guys' attitudes, the first 30 minutes will be independent. Then you will be allowed to discuss problems with each other. Okay, so that will be up to Mr. Leifeld to say, okay, now you can work together. But then tough nuggies. Then we can take whatever other time we need on Wednesday once I'm back. Okay. Don't know. Depends on what Mr. Leifeld says about if you guys just sat here like a bump on a log waiting for group time. So the reason I'm doing that is I want you to take time on your own first to grapple with the problems, figure out what you like may or may not be comfortable with, take some time to let it like work in your brain, and then talk with other people instead of immediately just jumping right to talking with other people.
And you don't want us to just split up the problems.
Correct. I do not want you to just split up the problems and use that sort of
was going to
technique.
be the plan, but that was like, wait,
Wait, can you go back?
that could be bad.
This slide.
Are you writing it down?
So you actually have this on one of the handouts that I gave you last week. You actually have this on one of the handouts I gave you last week with our triangle constructions. You have 2 pages about this.
Is there only one? Is
Yeah.
there only one assignment in 8.1?
Yes, it's 811. It was 2 days worth of homework. There's just that one thing.
I just wanted to make sure that I wasn't like 30 days behind on homework.
So if you want to justify the nicer proof, you can show up here that your fourgon or your quadrilateral will become 2 triangles. Your pentagon will become 3. Or you can draw from the center and make your reminder about the central angles. If you've lost this page, I can give you mine, but I don't really have a bunch of extras. And down here, we would just keep growing by 180. But then, like, if you got given a 100 gone,
Why couldn't it be an 102 gone?
right?
No.
Wouldn't that be easier?
102.
Well, okay, so 102
Well,
gone
I'm
would be
speaking
what?
Spanish translated to English.
102 gone would be what?
That'd be
100 times
180 0.
180.
180 0?
Zero. There are two.
Another 0?
Good job.
It's
Okay.
18,000.
So then,
180 0 0.
so then I guess to get back to 100, how many degrees would we need to take off?
360 no scope.
So what would that be?
Well,
That's
17, 8, no, 6,
180
40.
times
640.
98. Yeah.
17,640?
Yeah.
So we said for n, it's going to be n minus 2 times 180. Great.
Well, if I want to be multiplied by 100 and then times.
Multiplied in times.
Yeah, well, multiply is fancy.
Okay.
So then Fern.
Oh, no.
Oh no.
We learned this at like the start of this.
This is review before we have to start applying it.
You're so stupid.
It's so mean.
I know. But it's true.
This one is
It's
easy.
120, okay? It's
Well.
120.
Maybe I am not as smart as you, Connor.
No, I'm talking to Fern.
Well, maybe Fern is not as smart as you. Can you discuss how
Okay.
that can be found? And
Okay.
don't be mean about it.
So you
Fern
got
is
it.
helping.
You know 6 times x has to equal whatever, what is it, 4 times 100, 4 times 180.
What if I
right?
don't believe you?
Okay, well,
You
now
don't
that
believe me?
goes
Yeah,
right
like we
on.
have the formula, but what if
All
I
of
still...
the angles are 4 times 180. Do you believe that much?
All of the angles are 4 times
The
180.
total
Why?
interior angle.
No, what if I still can't recognize that?
Okay.
Don't kick stuff. It's not worth getting upset
N
about.
minus 2. N is 6. Can we at least agree to that?
No, but like, what if so COVID or whatever? I missed the previous couple slides that we did. Well, I don't know that. So you got to work without using that formula. How can you work Fern to finding those equal
Fern is
angles?
just not, you know, Fern needs to just come to class.
I mean, you're probably right. Is that necessary? That feels like a lot.
Okay. Well, you wanted to do it this way, so let's do it this
I feel
way,
like there's
Mr.
an
Hunt.
easier way.
Well, yeah, there is an easier way.
Yeah, it's called do what we said
No.
to.
No, what? No, okay, you know what? I'm just gonna.
Okay, 2 of these is 360.
Mm-hmm.
180 times 2 is 360. Do you agree to that?
I agree.
Then you divide by 6 because there's 6 angles. So you got 60. Then you multiply by 2 because there are 2 sets of 360 here.
That's a good.
120.
What?
Okay, that's okay. I mean, technically there is an easy.
Whoa, wait, huh? What?
I don't know.
You do it fine. My way works the best. I'm just being honest.
My way works the best. No bias or anything involved.
No, it's just
I
true.
don't know if this is gonna work.
Never be biased.
I'm never biased.
Connor Morris, no bias guaranteed.
No.
I got you.
You can just spam the undo button until it goes away. Or you,
I don't know if this
or
is
you
gonna
can
work.
slowly do that. I'm the least good math person ever right now.
Why is it not working?
Because it doesn't like you. Oh. I still like my way better, I have to be honest.
And then what do I do again? Okay.
Well, those are equilateral triangles.
Right. So, wait, where am I going with this?
Their angles are 60 degrees.
Exactly. so yeah, there we go. 60 degrees because equilateral triangle.
They're equilateral?
Yeah. That's how that works.
Says who?
Says math.
I mean, I would believe you that they're isosceles, but are you sure they're equilateral?
It's a regular hexagon. That's what says who.
But what if I don't?
If you don't think it's a regular hexagon.
No, but like there's a law that says that regular hexagons make
Yes, you said
they make
that at the
equal-
start of the year.
Yes.
that they make equilateral. That those diagonals are going to be the same length as the edges.
Yeah. Well, 2 times, but yeah. You want to know why? Fine, let's go into why. Okay. This is a 30, 60, 90 triangle. So this is times 1, this is times 2.
Wait, how do you know that's
We
30?
know this
Oh,
is-
I know why it's 60. Okay.
You got... Wait.
Oh, because it's 60, 60. Wait, why is the central... Wait, I think I'm almost there. I'm almost there. I'm almost there. I'm almost
Because
not
the circle
quite
in the
as
middle
less...
is because it's kind of the. So okay.
So
there's
this...
a circle. No.
Nice circle there. Stop it.
Okay. So the circle right here, that's 360 because each circle equals 360, and then that divided by 6.
Equals what? Is that the nicest handwriting? Do it in your nicest handwriting, she says.
That equals 60.
So, with an equal angular or equilateral, like a regular polygon, right? With a regular polygon,
Yeah, great.
you can defend, I don't think you'll be mad at me for getting rid of those. You can defend this math by using the knowledge that the central angle in here is 360 degrees. In a regular polygon, that can be divided by how many sides you have. But this is a hexagon. It works nice. Does that work for like an octagon?
How about we make it a dodecahedron?
Okay.
No.
Wait, dodeca? No, 12 is still too nice. Do you want 8 or 10?
10.
10?
A dodecahedron.
Dodeca would be
Stop
12.
being mean, Nate. Okay.
So hold on.
Okay, so it's n minus 2. So
You good? You ready?
Wait, I feel like this one is nice because it's
It is nice.
All equal.
6 times. Wait, it's 6. There's something with 6.
Is there?
Yeah,
No, there isn't.
because it's 6 times.
Okay, there's 10 of these.
Divided by 8.
Circle.
So it's 6 180s over 8.
Because I'm
36.
pretty sure that equilateral only happened because it was a hexagon.
Yeah, you're right.
Okay.
So hold on. Hold on.
Mr. Hudson.
Just to prove that I'm not just dumb. I am dumb, but I'm not just dumb. So when you were very indignantly arguing that yes, this happens because it hold on. When you were yelling at me that yes, this happens, they're equilateral because it's a regular
I said
You
it's a
weren't
regular
wrong.
hexagon.
You weren't wrong because it's a regular hexagon, right?
Well, that
So
was what the
in
question
a
was.
standard regular polygon, we get isosceles, but not necessarily equilateral.
You just take a calculator and you just do 180
180
6 over 8.
times, wait,
Why
180 times 6.
'Cause
Over
n minus
8.
2.
But this is 10. So times 8.
This is an 8.
No, this is a 10. This is a
Oh.
10.
There are 10 triangles there.
Wait, it's times 8 over 8. Wait,
Over
it's times
8.
8 over 10.
Okay.
What are we
180
dividing
times
by?
8 over 10.
I'm confused
Because
what we're
there are
dividing
10
by.
angles there.
Ah.
It's 800 to, what's 8 times 8?
10 to the 60.
What's 180 squared? Just,
Squared?
yeah.
That's a big number.
Wait, no, it's 180 times 10. I'm so sick.
That's
No. Wait, yes. Yes. No.
No.
No, it's 180 times 8.
Oh my god.
Oh my goodness. It's 800 plus 16 0, which is 960 96. I think.
Just
No,
90.
it should be bigger than that.
What if we do it for an octagon?
Okay.
Let's go ahead and back it down. I feel like 10 was a lot of sides for us. So if we do it for an octagon, what's the process you just said, Connor?
N minus
Jake,
2.
I'm guessing that you're with us. You're just not wanting to stand up.
You take N minus 2.
So what's n here?
8.
So n is 8. So we do
180
8 minus 2.
times 6 divided by 8.
Wow, that handwriting looks kind of Jake-ish.
I know. Okay.
So 6 times 180. 600 plus
240.
240. So 840.
Oh, that's why I did it wrong last
So,
time.
are you just
840.
do bad handwriting just to make extra of that?
I mean, but now her handwriting looks like yours, and I was saying that just to make her mad.
8.
What?
It's
Stop.
840 over
No,
8.
no, oh my gosh. Stop.
It's 8.
Ah, careful.
105 degrees.
105! Okay.
It should be.
Wait, no. What? Stop. Wait.
It's 840 over 8. Right?
You got that fancy wrist calculator.
That's called. Okay.
Look, there are not just Apple Watches. There are other smart devices.
That's
Yeah,
not
but Apple
right.
Watch is the only
What?
It's 6 times 180. I don't know what your thing is.
6 times 1. Wait, no, I did it wrong. 80.
I think that's 840.
What?
Your calculator is just bad.
Maybe it's because it's like the
What?
size of a grain of rice.
No, it says 6 times 180 is 1,080.
That's not 6 times.
Her
180.
calculator is just bad.
That doesn't
Should be
make
600 plus 240.
It's
maybe.
840
And then divided by 8.
What?
equals 105. Get a better calculator.
I'm okay.
6 times 180
Isn't it?
600 plus 816. No, 320.
Oh, it should be 480. So it's.
No, 6
It's-
times 180.
Wait, it is 1080.
This I'm right.
What?
Stop,
No.
You're dumb.
So
Oh,
8.
it's 108. Okay. Yeah, I am dumb.
Yeah, you are. I know what I'm doing.
I don't know how to read numbers. Okay?
Okay, I'm right.
It's 1080 over 8. So
We-
it's like, what,
we only-
1.5.
Connor, you and I only went halfway there. Because when we were doing 600 plus, we did 240 instead of 480.
Yeah.
So we need 600 plus 480. Be
Which
careful
is
judging
that.
technology.
And so
but
it's 135.
that's when the robots will come back and take over. When we pass judgment on
Because
technology.
it's 125 plus 10.
So, what then, if you can imagine, you are correct, you are right. If you can imagine a 100 gone, imagine with me, right? This, I know it's
Just
a
get a
16
circle
gone.
tool. Like,
Okay.
it's
No,
more
no.
accurate.
Oh.
So, if we imagine a
It's
100
a pie
gone,
now. Look at that.
if we imagine a 100 gone, the process there, which we already did some of the math, we said is 100 minus 2, so 98, times 180,
Which we already got.
so 1,706 divided by 100
1764. So it's 1,764.
in each angle? So we're saying
No.
each...
No, that's not right. It's 176.4.
Yeah,
76.4. Yeah.
in a 100 gone, each of these angles would be 176 degrees.
Wait, but
So
Like,
almost, yes,
wait.
0.4. Almost a straight line.
Wait.
4 degrees off of being
but like,
less than 4 degrees.
Even like an infinitely large shape still has to be less than 180.
I know.
Then
I know,
that kind
right?
of sucks. Wait, Jake, apparently you're
So, this goes into...
Fake
What?
Jake.
No, that's one of our 7th graders. Hey, so this goes into why when you zoom in on a circle, you technically, like, we talk about it being like a straight line if you zoom far enough in, because there's always a tangent line, right? There's a line that clips the circle.
That's not.
Hey, judgment. There's a line that clips the circle always, and right where it clips the circle, there's one 90-degree point, right? We can talk about it like it's a straight line.
So that's the circumstance.
No, this is just a tangent point.
Okay.
Yeah, that would just be a tangent point. All right, so moving on. What about how we find the exterior
360
angles?
for every single thing in yeah, because we did that on the homework. Yeah.
It's not 360 for every single thing. An 100-degree shape would have 360 exterior angles. It's like
I'm
n+.
confused at what you mean about 360 something something
So,
something.
Think about the n-1.
exterior angles for all exterior angles, they all have to add up to 360.
Wait, were you right?
Yeah, because we learned this at the
Wait,
start
are
of
you
school.
right?
We did this in the homework. Yeah,
Can we
yeah.
prove it?
Yeah.
180 minus the
Because you take these lines, make them. Okay, I thought that was
What?
the line tool. You take these lines, make them longer.
Okay.
And then you just take the circle.
You missed
tool.
one.
Did I?
Yes.
Oh.
Do not see the other arrow.
No. Of course I see it, and I'm just choosing not to do it. Where's the circle?
I'm confuzzled.
You take the circle, and then you make a big circle.
You make a big circle.
See?
It looks like a cool shape.
No, it doesn't.
I think we're like designing some sort of logo.
I think that's already a logo.
Yeah. Oh, let me see.
But wait, why do they add up to
Did you
360?
just say boy, why? Or did
No,
you
I
say
said wait, why?
Oh, okay.
Okay, because
Oh, I probably said but why.
here, look at this, Mr.
If
Hudson.
you heard a B.
This
Why.
No.
and this angle have to be the same. And then you got
Oh, it's because the
This.
arc. But wait, those arcs aren't central, and they're also not on the.
well,
They're not central arcs or what's
okay,
the
they're not
thing from the
the
edge?
same. 'Cause
Inscribed.
This isn't right in the middle of the
Inscribed
center.
arc.
I think so.
But this.
I don't know. I mean, I know this.
You got this
Well, if
bit,
you don't know, then I don't
this
know.
bit,
Oh yeah, right. Okay.
And this bit and this bit.
Why are you?
These bits aren't the same.
I
just
know.
ran out
You
of
should have
colors.
made it a different color.
I ran out.
No, you did not. There's literally
Of
a color
easily
right next
accessible
to the
colors.
blue one.
So wait, so this one is a hexagon again, right?
Yep.
And it tells us it's a regular hexagon.
Yep.
So what did you guys say we for sure know about the regular hexagon?
They're nice.
They're all 60 degrees.
They're all 60s.
Wait, shoot.
Wait, they're all what?
Why?
What's
the
all
interior-
60?
All the interior angles. Wait.
You're right, something's 60, but I don't know if that's the thing that we care about.
Oh.
The 60 that I think you're remembering
See, I told you there's other colors.
is that.
Oh.
So what is like this?
Actually, that's 180.
Just the orange?
No, the orange is
Oh, wait.
The orange we said was.
Oh, I know it's 120, yeah. Because for some reason I thought 60 times
And
2
then
was.
you do
Yeah,
180 minus 120, which gets you 40, and that happens for each. Wait, what?
That happens for any
60,
shape.
and then you just multiply by 6 because that's how many sides there are and that's how many lines
Yeah,
there
but
are.
it work. But how does it work for every shape?
I don't know. Ask Mr. Hudson.
Same reason.
Same reason. Okay.
So for exactly what we just showed, with the triangles from the center or the triangles from the vertex,
Because it's the same angle as on the inside.
we know that all of these will be the supplements to the interior angles.
Which are the supplements to the interior.
And the amount of supplements that we'll have is the number of angles that we have.
But
So if we wanted to write this out as a proof for a hexagon specifically, we're going to end up with 6 of the supplements to those interior angles. And we know that all of the interior angles add up to what we already defined, right? What we already
But
said.
we also know that this angle in the middle right here, this is 60 degrees, and we know it times however many of it there are in the shape is 360. And then we know this has to be 180 minus whatever this is. And so this has to be,
Not when
This
it's
shape.
not regular.
well, when it's regular, yeah.
Right, but we need to remember that we need to be able to apply this for non-regular shapes as well.
and you can also use remote interior angles.
apply it for all regular shapes.
Right, but be careful pigeonholing yourself into something that only works for regular shapes.
But the
Right.
other shapes are one.
If you can prove it in a way that will make it more flexible, do that. And this is what I was referencing last week. You guys got to knock off this 8th grade apathetic attitude of saying, but this way is easier. We need to solve these problems to the best that we can. Right? So when we are comparing, should I make a proof that works for all shapes or only regular shapes, squash the 8th grader mentality that wants to take the easy way out and take the challenge.
If you can do the one.
If your sentence starts with but if, analyze if it needs said. If it only works for regular shapes, we need one that works for all shapes.
Why?
Are you really asking that question, or are you just being an 8th grader?
No, like.
Not all shapes are regular. The
Okay,
rules
yes,
change.
obviously. But we haven't been asked a question about.
Yeah, we did. It was on the homework.
Yeah. Oh,
Oh, yeah, we did.
nice.
All right, but why? I forget what question it is, so I might just throw this under you.
Because you know all the interior angles of a triangle have to be 180 degrees.
What about here? How could you prove to me, and you can choose which one of these you want to use, except you can't use the regular hexagon. So quadrilateral, pentagon. Actually, I think it might look better if we use my paper.
Yeah. Okay.
Well, you know
What do you want, the quadrilateral or the pentagon?
Quadrilateral.
Quadrilateral might be easier to do.
Yeah, because they're all right angles.
Give me a second, and if it'll focus.
Oh, okay.
Those giant bold statements that you keep saying that only apply to certain regular shapes.
So only apply to certain regular angles. Well,
All right, hold on a second, and I will make it nicer for you. Stop poking the board.
Just put it down.
Okay, not meaning to do that. Get out of here. All right, here you go.
But we know the insides are 360. Oh.
Jake, you don't need a circle.
No, that doesn't matter. That's not how it works.
Jake, you don't need
Yeah.
a circle. Circles aren't necessary.
Weren't you the one who drew the circle last time?
That's true.
Yeah, but now I've changed. I
But
don't
now
like
I've
circles
changed.
anymore. What are you trying to do?
Why did I put delete next to infinite cloner?
Ask the coders.
I don't want to be confused.
Okay, guys. A, B, C, D. A plus B plus C plus D equals 360. E,
It's an interesting B. It actually looks like a Greek symbol.
H,
So then,
E equals 180.
180 minus A.
So, generally you got 180 times 4.
Hey, be careful leaving that. What you have written is E equals 180. You want to go ahead and finish that statement?
180
Minus A.
minus A. And then we can write it out for each of them, but that's just,
Right.
you gotta take a lot of time, because they're all 180.
Is that a 380 or 180?
It's 180. And then you got 180 times 4 minus this value up here, because that's all of them combined,
Right, and then stay.
equals 360.
Yeah, okay. Oh. Okay.
Does that make sense to all of us?
Yes.
We don't have to write out the whole thing if it makes sense to us.
Yeah.
So there's a lot of substitution that can be applied here. So I love what Connor said with this, because then we can also move this around, isolate A, do the same thing with B, C, and D, replace things into our equation, fill things like there's a bunch of ways that we can do this as long as we keep recognizing those relationships. but it solves differently for regular than non-regular because things aren't nice, right? We can't just say, oh, all of these are equal, all of these are whatever. I think that's everything we needed to cover
Do you
today.
know when
Yeah.
they post map testing grades on like Infinite Campus?
I have no idea. I think you should be able to access them now, but I'm probably
you can't
wrong.
see the new ones.
Okay, well, then I'm wrong, so.
Why do you care what your
Because my mom does.
All right, 8th grade today is at 12:18.
like over 290?
You're at 12:18 today?